MyEA is a white box, trustworthy industrial intelligence platform for complex energy and industrial systems. It connects physics-based modeling, predictive AI, and live process control in one coherent workflow. The objective is to improve performance today and over the full life of the system. Making renewable energy more competitive requires more than better hardware. Operators must reduce maintenance cost, extend system life, and manage increasingly complex assets under uncertain conditions. Yet many systems still rely on static control. And many AI tools remain black box by design. In critical industrial processes, that is not enough. Industrial systems need more than prediction alone. Decisions must also be understandable, traceable, auditable, and consistent with physical reality. This is why white box, trustworthy AI matters. It provides a more transparent and reliable foundation for critical engineering decisions. MyEA starts from physics-based digital twins. These models capture process behavior, constraints, efficiency, operating limits, and degradation. From there, MyEA supports model-based optimization, synthetic dataset generation, data preparation, surrogate AI training, scenario analysis, and real-time model predictive control. The result is one end-to-end workflow from physical understanding to predictive intelligence and intelligent operation. MyEA helps teams move safely from offline validation to live process control. First, strategies are tested in a secure virtual environment. Then adaptive model predictive control uses predictions and constraints to optimize decisions ahead. Finally, this logic supports live operation with continuously updated control actions. This creates a practical path from safe testing to adaptive industrial control. Traditional control often applies similar logic across the full life of an asset. MyEA goes further with state-aware and degradation-aware control. It updates decisions using predicted behavior and process condition. And it balances output, energy use, equipment wear, and long-term value. This enables better trade-offs across the asset life. MyEA is relevant across multiple domains. In hydrogen and power-to-X, it helps compare strategies and adapt to variable renewable input. In water and desalination, it supports plant efficiency and operation under constraints. In industrial energy systems, it helps reduce energy cost, coordinate electrified processes, and improve safe, efficient operation. The practical value of MyEA lies in its coherent workflow. Digital twins, optimization, synthetic data, surrogate AI, and predictive control work together in one stack. This reduces dependence on large historical datasets. It accelerates validation. It improves transparency. And it builds a stronger bridge from engineering models to operation. The transition to renewable and electrified energy systems is increasing industrial complexity. At the same time, operators face stronger pressure on cost, reliability, and smarter asset use over the asset life. This makes transparent, adaptive, and engineering consistent AI strategically important now. MyEA is designed to answer that need. MyEA transforms complex processes into better decisions. More transparent. More adaptive. More cost-efficient. More aligned with system reality. From physics-based modeling to live process control, MyEA helps operate complex systems more intelligently over time.